not trying to be mean. I don't know what the hell.
He was just saying that. I didn't.
No, man, he's like that. He trips a lot. But anyway,
I'm not really good at that.
I could see that you are really struggling. Like, you're basically, when I come to you, you say, I didn't understand the whole section. Yeah. You're basically saying that, whereas when I go to another student, they're saying, no, I'm just not sure where to put this number. That's a different kind of question. Yeah. That means you need one-on-one. Because didn't he sit here with you?
I'm not really good at studying, like, with anything.
Well, how are you going to pass? How are you going to get a degree then? What's going to happen if you don't pass the class?
I'm done. So.
Then you got to just go and start working?
Yeah.
I wouldn't want that option. I would try to figure out how to study. You know, when you do start college, they put everybody through a how to study workshop. Did you attend that?
No, is that when I came to the school, it was like late. I committed late, so I had to do all the paperwork.
Well, if you want one-on-one, you could come to any of my office hours. My schedule's posted on Blackboard. It just says right down the side, instructor schedule, and it'll tell you when I'm in my office. Or you can go to those other places I told you. Any of those you'll get one-on-one instead of, being in a classroom. Okay, you can come to me. I'm completely happy to do that with you. Okay, I would like you to find this for sometime later in the class, this paper where you were like practicing. I think all you saw so far was what, up to 3?
5.
Oh, you saw all the way up to 5? Okay, that's good to know. I'm going to add a few more problems to this, and we're going to jump on Socrative, and you're going to feed your answers in. But I have them written here because when I type them, they look slightly different, so I wanted to give you a printed version also. So I have, did everybody see that I created a schedule for you? What to do well on this next test. Please don't be a cowboy and do whatever you want and just come in here hooting and hollering saying, I didn't know I had a test, because you won't pass it. I've already heard the sob stories about this test, this particular test for Chapter 7. You're going to like the next one. The next one's going to be a piece of cake for you. But 7, you must put some exerted effort into it. So if you stick to the schedule that I prepared for you, you'll spread it out a little bit, the most feasible amount each day so that you don't start panicking. You can't pile up or else you'll start panicking. So read that announcement that I sent out yesterday. It told you what to do today, what to do Friday, what to do Saturday, what to do Sunday, because you're caught in a situation where I'm going to finish on Tuesday and you're going to test on Thursday, and that is not a comfortable situation. It's not like finishing it on Thursday and you got the whole weekend. So you got to play your cards right. You can leave it right there, so that you have very, very little to do on, almost nothing left to do on Wednesday except practice tests. Okay? So we're going to get started on the section that we got to kick out of the way so that we have some time to do our Socrative activity, because I need another activity grade for you, participation grade. Now, all of these will also be typed into Socrative. You'll see the same problems there. There'll be more than just 7 problems. I think there's maybe 10 or 11, something like that, because I added on a couple from 7.4 and a couple from 7.5 or whatever. Yeah. And today I'm doing 7, what am I on today? 7.5? Okay, so there's a couple from 7.4, a couple from 7.5. All righty, let me get a clean copy. Oh, yeah. Every time you do an activity, I have to get to work with it. Okay, let's go. We're going to start 7.5 now. This will just be for later. I'll try to finish like early so you can continue working on practicing these things. I think this section's easier than the other ones, but you do have to memorize the formulas, which again, that's why I gave you that stretched out schedule that starts today, because you need that time to keep practicing the formulas. That's a lot of why people can't do a problem. They know what they're doing, they just don't have the formula in their head. So you need time to practice those. Okay, so if you're looking at the sheet here, what happens with these problems is that I'm going to be giving you like some weird angles. You guys know how to handle 30 degrees, 60 degrees, 45. You can also handle anything that's related to those angles. Like I could give you 150, but because 150 is related to a 30-degree reference angle, it really turns into all about what you know about a 30-degree triangle. So anything that's related to 30, 60, or 90. However, what if I throw you something like this, and I ask you, without using the calculator, I want to see your radicals, your fractions. No calculator, and I tell you to do cosine of 75. When you go to 75, do you see that the reference angle is still 75? It is not related to 30. It is not related to 60. It's not related to 45. So what are you going to do? You need new formulas. Formulas that will turn it into a problem so that you're related to 30, 60, or 45. So that's what these formulas are about. You have to memorize these. I can tell you little things that are similar with respect to these versus these. Like, for instance, all of the cosine formulas are what we call homogeneous in the front, homogeneous in the back. In other words, see this product right here? It's made out of nothing but cosine. Whereas in these formulas, this is a hybrid product. It's made out of different things. See, part sine, part cosine? So in all these cosine formulas, the front's homogeneous, same trig word twice as that product, same trig word twice in the back. This formula and this formula is like that. So if you can just remember that, it will help you to memorize both formulas at one time. What you also need to eyeball on this formula is notice that in the cosine formulas, whatever you start off with, it is the opposite sign in the middle of these two products. That is true here as well as here. So homogeneous, homogeneous, same thing here and here. And this will be the opposite of that. That's the opposite of that. But look what's happening in this one. This one is not homogeneous. It's a mixture of sine and cosine, here and here, as well as here and here. The signs are the same, unlike the cosine formula. The signs are the same as what you started with. So those minor differences in the formulas are what you should hook into instead of flat out memorizing them the way you see them. You want to always look for similarities and differences. That will cut down on your cognitive load, how much you're stuffing into your brain, and help you be more successful at memorizing. So, and then there's tangent. How do you handle tangent? Okay, tangent, those formulas go like this. Now, you can be looking at the formulas while we do the problems, obviously. They are fractions, and they are the ones that give you a pretty good run for your money when it comes to the algebra part because they're fractions. The sine and the cosine ones are easier. But basically, the formulas here, if you're going to add two angles together to get some weird angle that I'm giving you, like a 75-degree angle, you're basically just going to drop the parentheses and rewrite it as the numerator. See, it's just be tan of alpha plus tan of beta. Okay, same as this, like you're doing the distributive property. Then in the bottom left-hand corner of both of these fractions, they both start with a 1. The sign on the bottom, opposite of the top, and then just take these two quantities, the tan of alpha and tan of beta that are in the top, and make a product in the back right-hand corner, the bottom right-hand corner. Same thing here and here. Both these formulas are the same. You literally write what you see here as though you were distributing the tan as your top. See, tan of alpha minus tan of beta. Both of them have a 1 and a product of these items right here. Bottom sign opposite of the top. Okay, let's do it. Let's do these problems. We're going to be calling on one formula or another as we go through these. Now, I have them memorized. You can just look at the sheet. Okay, so it says, determine whether the statement is true or false. So what I'm going to do is I see that they have they have a certain expression here. I'm going to see if I apply the formula here, will it be the same? Because then I can determine if these two sides are the same. Okay, so look at your formula sheet. Whenever you're doing sine of two angles added together, those are the formulas that are hybrids. They're a mixture. So it's sine of alpha, cosine of beta. In the formulas that have to do with sine, notice on your formula sheet that whatever was in the parenthesis, it's the same sign in the expansion. I am now expanding. Okay, one thing you got to be careful about is that you're going to switch angles. See how the alpha was with sine? Now it's going to be with cosine. But still, you're going to have another hybrid mixture here. Doesn't matter whether you write cosine or sine first. When you do this back product, just make sure you got part cosine, part sine. If alpha was with the sine, it is now with cosine. If beta was with the cosine, it's now with sine. So they kind of, those angles switch the trig words that they are exposed to. Okay, but hybrid product, hybrid product. Okay, so that is what this boils out to when you expand it. Is that equal to this? What do you think? Yes or no? Do they match? No, they don't match. And there's no like terms there, are there? No, sine of alpha, sine of beta, and then one of those. Okay, so determine whether the statement is true or false. It is false. All right, let's do this. That looks like a theta to me, not a 0. So they want to know, is this equal to this? Well, let's expand it. Go look at your formula sheet. You have formulas for cosine. Those are the ones that are homogeneous, cosine, cosine, sine, sine. And you're going to use these as the two angles. Okay, so those formulas go like this. Cosine, cosine. These are the two items that were in the parentheses, in the front and the back of the parentheses, so that's what I'm using here and here. In those formulas, whatever the sign is inside the parenthesis, you switch it in the expansion. And then we're going to do another homogeneous pair. This one was cosine, cosine. This one will be full sine, sine, sine. Again, the pi over 2 and the theta. So is that equal to what they said it's equal to on the right-hand side? No, they don't match, so false. Okay, select the correct choice that completes the sentence below. They just want you to state the formula for tan of alpha plus beta. All right, let me use this for my fraction bar. So it's just tan of alpha plus tan of beta on the top. You can look at your sheet. So these first three are very easy. You're just reiterating the formula. Plus tan of beta. Then on the bottom, in the lower left-hand corner, a 1. Switch the sign. Look at what the sign is on the top. Switch it. And then make a product of these two in the bottom right-hand corner. Tan of alpha, tan of beta. That's it. And then pick the one that matches. Can't be that one because the signs are wrong. Can't be this one because it's got a negative on the top. Blah, blah, blah. Can't be this one because the signs are the same. Signs are the same there too. Has to be this one. Plus on top, minus on the bottom. Okay, actually moving to the real problems now where you're actually using it. You got a break in the last section from spinning around the circle, but now we're back to that. Most of the book is that. Because the last section was the plugging in and doing the proofs or the identities and simplifying. All right, so now what I want you to try and do, here's the gist of the whole section. Try to rewrite the number I give you using the good old favorites, 30, 45, and 60. Now you know that these are all sum and difference formulas. These are all called the sum and difference formula. So you're going to create whatever I give you by either doing a sum or a difference. This one's kind of obvious. Which two angles have we worked with over and over again that either add up to 75 or subtract to give you 75? Yeah, the 30 and the 45, right? 30 and 45, 75. So they love giving you 75 because they know you can easily use two of those favorites that we keep concentrating on to get the angle that you see right there. Now, you don't have the ability to give an exact answer right off the bat for 75, but you can do it with these formulas. So this is going to be, I should probably do this on paper. You can try and squeeze it in there if you want, but it just annoys me to try and squeeze it in. So sine of 30 plus 45, that gives me the 75. And then I try to apply the formula that I just learned. The sine formulas go like this. They are hybrid mixtures of sine and cosine. Whatever is in the parenthesis, the expansion bears the same sign. And then another hybrid mixture back here. And I don't care whether you go sine times cosine or cosine times sine. Just one of each, whichever way you want. But do remember this. This you have to remember. If the 30 was with the sine, now give the cosine a chance at it. And if the 45 was with the cosine, it is now with the sine. Okay, what does this mean? That you need to know the numbers to complete the problem. You need to know the numbers on a 30-degree triangle, on a 45-degree triangle. So real quick sketch, unless maybe you have them in your head, that would be fine. If that's what you're doing at this point, some of you are. Here's a 30. Let's see, this would be the 1/2 short leg. This would be the long leg. And this would be the hypotenuse. That's if you're basing everything off of a radius of 1. Okay? If the radius, because you know you're allowed to let the radius be whatever you want. 1, because those are small numbers. But it better follow this. If it's a 30, 60, 90, short leg better be half of the hypotenuse. And you should be able to multiply the short leg by square root of 3 to get the, and of course those values do follow that. If you don't like the fractions, you could let that be 2. That could be 1, and that could be square root of 3. It's up to you. Okay, what else do we need? 45? Now, you could draw that if you want, but don't most of you have it memorized that the legs on a 45, it's real easy to memorize this one, are both square root of 2 over 2? So if you don't need to draw the picture, don't draw it. It's up to you. If you like to have something visual sitting there right in front of you so you can concentrate, I know a lot of people are like that. Then do that. Okay, you're going to be looking at these two pictures as you finish this problem out. Okay, here we go. We're going to do something times something. Sine is the leg that goes like this. Label them if you don't have that ingrained in your memory. The cosine is the horizontal leg. Sine is the vertical leg on this triangle as well as this triangle. So sine of 30, you should be looking at the 30-degree picture, 1/2. Take it right off the picture. Cosine of 45, square root of 2 over 2. Plus, and then something times something again. Those somethings are sine of 45, square root of 2 over 2. That's that piece. They're both square root of 2 over 2. And then, let's see, cosine of 30, get your eyes back over here on the 30-degree picture. The cosine is the horizontal leg. And then just multiply. Get this thing cleaned up a little bit. Maybe write it as one fraction. Okay, when you're multiplying fractions, it's top times top, bottom times bottom. If you don't remember this, when you're multiplying radicals, as long as they're the same kind of radical, these are both square root. When there's no number there, they're both square root. And you're multiplying the same kind of radicals, you can multiply the radicands up underneath the same radical. Now, different ways I have seen my math lab accept the answer. They definitely like you to bring it together into one fraction, and you can do that as long as the denominator is the same. Okay, but I also see them doing this. I don't know why they need to be doing this, but you can take this, right, I could write this like this, maybe so you'll understand how they sometimes write it. This is the same thing as having a 1 out here. Therefore, if you want to pull that 1/4 out front as though it's a coefficient, I have seen them write the answer like that. I don't think they'll mark it wrong, though, if you write it like this. And then they pull this off to the side. It means the same thing that I have here, where you just pull off this fraction 1/4, you pull it out front as a coefficient. So those both mean the same thing. They're just different ways of writing them. I just write it like this. Okay, stop me if you have any questions. All right, let's go to the next one, which is number 5. Okay, let's get more practice. These are the ones that are kind of, the tan ones are a little bit more algebra and a little bit more annoying because you're starting off with a fraction, but it is what it is. First, decide on the split up. What could you split up 105 into while using the numbers that you've been using a lot when you do triangles? Okay, so 60 and 45. All right, so let's write this as tan of 60 plus 45. Then the next thing you're doing is referring to the formula for the sum of a tan, which goes like this. You distribute. It's like you're distributing the trig word tan. It's tan of 60 plus tan of 45 over 1 in the lower left-hand corner. Switch the sign, do a product. If you need pictures to refer to as you complete this problem, because we're going to do a lot of plugging in and a lot of simplifying. I'll jot the pictures down for you over here. At 60, long leg is across from the 60. Short leg is across from the 30, and this can be represented as the 1. If you need a 45-degree picture, put it there, but it's both legs are square root of 2 over 2, while the radius is 1. Okay, and then start plugging in. And every time you plug in, you're going to be thinking about one of those triangles that you have there. Okay, so now, does everybody remember here? I don't know if I need to keep writing this over and over again. Tan is y over x. So in these pictures that you're seeing here, this represents the y, also known as the sine, and this represents the cosine. If you think that that's not firmly ingrained in your mind, since that's going to appear in 100% of the problems on the test, you better write that. You don't firmly have that ingrained, that this guy is called the sine, also known as the y value. This guy is called the cosine, this horizontal leg, also known as the x. That is true for any right triangle. Piece that goes up like this is the sine, or the y, and the piece that goes like that's the cosine. That's been true since chapter 6. It should be gelling with you by now. So now let's do this, because some of these you're going to choose not to show too much work. Tan is 60. That's going to be a little bit of a mess. Okay, let's go to 60. Let's do a tan. We're doing y over x now, remember, because tan is y over x. So y, this is what I mean, we're going to have to simplify a lot. So y over x. Just leave it there for a minute. I'm just going to plug in right now. That one, I don't know if you want to mess with writing too much there. If you're doing the tan of 45, isn't it y over x? Just 1? It's the number 1. Why do a mess of a fraction there with a square root of 2 over 2 over square root of 2 over 2 when it's just 1? Okay, so when you're doing the tan on the 45-degree picture, the y and the x match, therefore the tan is 1. So there's a 1 right there. Let's keep going. Got a 1 down here. And then we have a product of tan of 60, tan of 45. We just discussed that the tan of 45 is a 1. Whereas this looks pretty messy. And I know I'm going to write this same thing right here. So I'm going to clean this up right here and now. When you have one fraction stacked on top of the other one, to clean it up, float the bottom to the top and flip it over. So float and flip to clean those complex fractions up. Let's get this risen to the front, to the top, flip it over, cross it out so you don't think about it anymore, and then notice the things that cancel. Because in noticing that you have a fraction up here. So now, looks a little bit better. It's just square root of 3 plus 1. And what did this just reduce to? Square root of 3, which is the same thing I was going to do here, only I cleaned it up already, so that's square root of 3. What do you think I still have left to do to this problem, having nothing to do with the trig, but having to do with your algebra and simplifying it? Yep, you got to get the radical out of there. Do you know how to get the radical? Should I multiply by 1 plus square root of 3, or just square root of 3 square root of 3? Okay, so we got to go over that. You know that whenever the radical is attached to a number by a plus or minus, it's that whole full-blown conjugate that you got to use. Anytime there's one of these involved. When that's not there, just square root of 3, then you multiply square root of 3 square root of 3. Then it's a simple kind of a simpler kind of simplifying. But here, negative or positive involved, you have to rewrite the expression with the conjugate sign. And whatever you're multiplying the bottom by, I told you these were kind of a pain because this always happens in these problems. You got the fraction to get rid of that's at the top, then you have the radicals hanging around. All right, we have shortcuts for some things. There's a shortcut for foiling that out. I mean, if you must, get in there with the arrows and go this times this, this times this, this times this, that's a pain. That is just a waste at this point. You should know for conjugates, it's just square minus square to get all that foiling done that I just talked about. When you square minus square, you could either be looking at this one or this one. You don't need to look at both. Okay, square that, you get a 1. Square this, makes the radical pop off, and put a minus in between them. So your bottom becomes negative 2. Okay, doing what we need to do on the top. Okay, let's see if you understand what you got on the top. Don't you have a 1 in both of those, a positive 1, and also a positive 3 in both of them? So that is the same exact expression as that. It's called squaring. There's a shortcut for that as well. You are squaring the same quantity. You're multiplying a quantity by the same one. That's the same thing. Write it like this or like this. It doesn't matter. Both of these have a positive 1. Both have a plus. Both of them have a square root of 3. So that's basically what you're doing. Well, there's a shortcut for that too. You could, again, you could go bam, bam. You could do the third or the fourth, do all that multiplying, collecting like terms, or you can just know this. Square, double, square. If you keep practicing it, you will get good at it. The beauty of using the shortcut is there's no arrows, there's no collecting like terms, there's just you going right to the answer from here. Square that. Square that. The doubling part, I'll show you how to focus on that. Okay, so when you square this, you get a 1. I'll put my work right here. When you square the back, you just get a 3. And the doubling part that they're talking about, just multiply these two together. Put them right up against each other because that's what you do when you multiply. So multiply that times that, but then double this. Double the coefficient, not that number. So 2 square roots of 3 is the middle term. Let's put the signs in. Anything that comes from squaring, positive. They are positive. You can't square and get a negative. So that's positive. This is positive. Then the sign on the middle term will be whatever was in the parenthesis. So if it's a plus, it's a plus. If it's a minus, it's a minus. But anyway, I just reviewed with you the 2 shortcuts that there are for foiling. They start talking about these in MAT 1033. They start using them a little bit more in 1105, but by now you should be using them because you have much bigger fish to fry. Okay, only like terms there are the front and the back. Okay, anything else you see that I could clean up? You can, they don't like you to have negatives in the bottom. So you could divide you could float the negative to the top, but if you want to get rid of the negative and reduce it, because some of you were saying 2 goes into all these, you could just divide everything by -2. That'll make the negative in the bottom go away. I'll just write it like that. Okay, so finally, the cleanest answer you could give. 4 divided by -2, -2. 2 divided by -2, -1. I'm not going to write the 1, and then comes the square root of 3. And then on the bottom, isn't there just a 1? And therefore, I don't need to write it. That's your answer. After all that mess, it comes down to that. You've got to be pretty good with your algebra and your simplifying. But that's only when you get to the tan. The sine and the cosines are not like that. It's just the tans that are pretty easy. Okay, I feel like you could do most of these problems just with that, but let me do a few more because you're going to be thinking they're different. Like I'm sure some of you think these are different just because they're in pi form. They're not. You guys learned many times how to convert something to degrees, which I know you're more comfortable with. The only time you're forced to keep it in pi form is when somebody says, solve the equation. They love the answers in pi form, so what can you do? But if you're not looking for an angle, you can put it in degree form. So go in your calculator. Why don't we do the bigger one? Let's do number 7, because 5 pi over 12 is going to be the same thing. Figure out what 23 times 180 over 12 is. What is it? 345? Okay, so we're doing sine of 345. All right, so probably some of you are thinking, I don't know any two numbers that add up to 345 that are related, that are 6. If all you're using is 30, 60, and 45. However, I already know that 45 is one of them just because it ends in 45. But the 300, do you know that the 300, when you spin to 300, what kind of reference angle? Let's see if you can see that in your head. When you go to 300, what's the reference angle? It's 60, right? Isn't there 60 left between where you've stopped and where you were headed? So if it's 60-degree reference angle, finding the sine of 300 is the same thing as finding the sine of with a 60-degree reference angle. As long as you draw your picture in, what quadrant will we be in if we go into 300 degrees? We'd be in quadrant 4, right? So you can treat it as, since the reference angle will be 60 once you get to 300, you can treat it as though you're finding the sine of 60, only you got to make sure to use the negatives and the positives that exist down in quadrant 4. But really, there's a lot of big angles that relate to 30, 60, or 45. You just have to adjust for the quadrant. So I'm going to write this as sine of 300, because that is related to 60-degree reference angle, plus 45. There's my 345. In that way, I have this funky angle that I really couldn't have done if I just left it as a 345, but then I can do when it's split up. So I'm going to do it on paper, draw the pictures for you. I want you to have visuals for what you're doing so that hopefully I can get to a few more students as far as understanding what's going on here. Okay, so we started right there. I'm going to write the formula. Okay, sine formulas. That goes sine, cosine. So sine, cosine. Whatever this sine is, it matches. That's where the memorization comes in. And then it's a sine cosine product again. Write the cosine first if you want. Just make sure it's part sine, part cosine, and switch these. 300 is now going to go with the cosine. The 45 is now going to go with the sine. Now, if these are the individual pieces that you see in my expansion, the 300 and the 45, you need a picture where you've rotated to 45 and one where you've rotated to 300. so that we can keep looking at it. Okay, here's my picture for 300. I'm going to go swing right here. Stop at about 300, knowing that this would have been the 360 mark, and I'm going 300 degrees. That would mean that this reference angle is 60 degrees. I had to stop before I got there. Okay, that being the case, that's the reason that the reference angle is so important in this class. It develops the entire rest of the triangle and allows you to proceed with the problem. Across from the 60, long leg. Across from the 30, which would be right in there, 1/2. Now let's see, aren't the y values negative here? That's what I meant by, hey, draw your picture and then adjust for what quadrant you're in with respect to what's negative and what's positive. So that you're really using 60, the information about a 60-degree angle, all you're doing is changing the negatives and the positives based on what quadrant you're in. And then, of course, that would be the 1. Okay, there's my picture that represents 300 degrees. A rotation of 300 got me 60 degrees before the 360. That 60-degree reference angle allowed me to get long leg, short leg, hypotenuse. 45, if you need the picture, here it is. If you don't need it, don't draw it. Both of them are the same. That's the only reason why people can keep it in their head. Okay, once you get there and you have a visual to look at as you plug in, the rest of it's multiplying. Okay, we're going to multiply this times this, so just get yourself some parentheses going. There's an addition sign, and then we'll have another product back here, which will be that times that. And I'll keep switching my vision from the 45 to the 300. Okay, so when I'm doing 300, the sign, remember it's always this piece right here. So square root of 3 over 2, negative. And then, let's see, what's next? Cosine of 45, square root of 2 over 2. Then come back here. You got to keep looking at the formula so you know what to fill in these blank spots. This blank spot stands for sine of 45, square root of 2 over 2. This blank spot stands for cosine off of the 300-degree picture. Get over here. Cosine is the horizontal leg. Sine is the vertical leg. Okay, the rest of it, algebra. Top times top. Bottom times bottom. Same thing over here. Okay, they have the same denominator. You can pull them into one fraction if you want, which they're probably going to do. And you can write this top or this top first. It doesn't matter. Just, you better get the right signs, though. I need for you, even if you switch them around like this, to state that square root of 2 was positive while this guy was negative. You can pull this out if you want. You can note that that's a 1, and you can write this answer like this. I tend to see the answers given with the positive term first and then the negative term, but you can write it either way. On the test, I give you credit for either one. Okay, and I really am not interested in you doing this on the test either, but my math lab likes to write it like that, so I'm exposing you to it. Okay, let's go to, all right, we're going back the other way. Now we're going to have a lot less work. Let's see if you can understand why we're going the opposite direction now. Look at number 8. I don't know if you get this or not, but do you see that they are starting the problem with it already expanded? You want to condense it back down to just a single trig word. Right now you're seeing a mixture of 2 trig words, a mixture of 2 trig words. So the way these start is you just try to think, is that the way it looks when you're expanding sine or cosine? Which one is that? Look on your sheet if you need to. It's sine, right? Because isn't the sine expansion the one that goes sine, cosine? It's a mixture. So you're going to bring it back to its original form where it just said sine one time. Okay, going back the other way. You don't have to write this out. I'm just... Okay, so that's what they give you. you're bringing it back to its original form, which this is the sine expansion. So go back to just sine, and this is what it looked like before they expanded it. What were the angles inside? Yeah, 60, right? Because aren't the 50 and the 10 the things that must have been in here? This is a lot less work because you definitely don't have to write that. I just wanted you to realize that that's what you're usually doing. In all the 7 problems that I have done today, or 6 problems, we did this part. But if they're going to give you this part and you're supposed to be applying those formulas, the only thing you can do is go back to the original state. That takes you to sine of 60, and you are expected to know what the sine of 60 is. Some of you are going to start to do these in your head pretty soon and picture in your head, hey, if I got a 60 right here, hypotenuse, leg, square root of 3 over 2. Okay, if you're at that stage already, good for you. I just don't want decimal answers. If you want to jot down a picture that you can look at while going to the next step, here's 60 degrees, because that is always where this angle belongs, right at the origin, the reference angle. The sine is this piece. This would be the cosine. This would be the hypotenuse. Anyway, they're only asking you for the sine. So no need to even put those other numbers on there. And that's how it ends. A lot less work. If they give you the expanded side and expect you to go back to the original, maybe a third of the work, as opposed to the ones I've done thus far today. Okay, number 9 is the same deal. It's already expanded. Go back. Which formula is that one? That one's cosine, right? The way you can tell is because it's same trig word at the front product. That's where the memorization will come. Same trig word at the front, same trig word at the back. And when it's like that, it has to be cosine. All you got to remember is, hey, what's the deal with the pluses and the minuses? So let's see. I'm going to go back to cosine. I'm going to put a parenthesis so I can put the angles in. The first one that they mention is 15. Second one is 30. Now I want to think for a minute. If in the expansion there's a minus, what did the original one used to be? Plus. Do you want to tell me something? Oh, yeah. Thank you. Sorry. Okay, so all I was doing is I was just looking at how this looked and trying to recall the formula. So I recall in my mind, yep, the one that goes cosine, cosine, sine, sine is the cosine. So I bring it back to a single word of cosine. All those formulas started with the 2 angles that you had split it up into, but you can see what they are right here. And then the last thing I think of, not that you need to think of these things in that order, is if this sign is minus, what should that one be? But if you look in those formulas, you'll see that they're opposite of each other. Now finish it. Okay, this is really what? Cosine of 45. What is the cosine of 45? You might not need a picture for that. Yep, we can memorize those pretty darn easy. These, I don't know what to tell you about the fractions. I mean, you could go completely degrees here if you want. That seems like a lot of work to me. Or you can just try to resolve yourself to the fact that there's some fractions here. I think you guys do know how to do common denominators. And you can leave it as fractions while you're in the midst of the problem, and then think about it in degrees when you go to do the calculation at the end. So 6 of one, half a dozen of another. I don't know what's going to be best, but here it is. Okay, first of all, what formula is this? It's already expanded. Sine, cosine, cosine, sine. Is that the sine or the cosine formula? Okay, those are the sine formulas, so think of that first. In those sine formulas, what's the relationship between the sign that they use in the expanded version and the one that's in here? Same. Okay, then what is the thing that goes in front and back? Just look at whatever they mention first, that goes in front. Whatever they mention in the back, that goes in the back. Not that bad, because can't you really pretty easily change a 6? Change a 6 into a 12? So just do that. So 2 and 2 And it would be pi over 12 minus what, 10 twelfths? So 10 twelfths. Let's keep going. So that would be what? 1 minus 10, negative 9? And maybe reduce that. 3 goes into the top and the bottom. Okay, so that's as far as it reduces, drop down the sign. All right, now, how about this? Do you remember that there were odd and even functions that keep slipping into these sections? They have slipped into several sections. Is sine an odd or an even function? That's an odd one, because only cosine and secant are even. This is an odd one, and with the odd ones, you can get rid of that pesky little negative, get it out of your way so that you can go about your business in an easier fashion. So, because this is an odd function, odd functions, that negative floats to the front. If it was even, you would just erase it. All right, maybe now you want to put it in degrees so you can tell what 3 pi over 4 is. What do you, how many degrees is that equal to? 135? Okay, good. So this is really minus or negative multiplied by the sine of 135. Why don't we get ourselves a little picture? 135 degrees is the cousin to 45 degrees, because when you spin to 135, you are going to have a 45-degree reference angle. So doing the sine of 135 is just like doing the sine of 45, only you got to adjust for the negatives and positives. That's why you have to draw the picture. Go to 135, draw that rotating arm, which is the hypotenuse, drop down, realize that you've gone 135, and if you understand that this is the 180 mark, that means that where you're at right now, at 135, from here to here is a difference of 45. Therefore, this square root of 2 over 2 is the sine. This is the cosine. We only need the sine. We need that, the leg that goes up and down. So I come right in here right now. Sine of 135, square root of 2 over 2. But this thing had a multiplier of negative 1 that I yanked out. Yeah, we're not, I took 11 and 12 out of the problems. However, for the test, I took them out because the TAM problems, some of the ones that my math lab came up with, the numbers were just, they were ridiculous. I went in there and worked them all out before, and some of the TAM problems were like 12 steps just to do that. So that's why I took them out of your homework. But please let me do an example for you. Let's go with the easier set of numbers, which would be the ones that were given right there, the 3 and the 5, just so I can show you how to move between two pictures. But we've been doing that the whole section. Haven't we been drawing 2 pictures for each problem and getting our eyesight to focus on both of them? This is just more of that. Okay, so I'm going to get a piece of paper. This is going to be the last one that I work out. Then we're going to go do our activity. And I don't know if I'm going to do the whole thing, but here we go. Okay, so it says sine of alpha is equal. This is just practice of drawing 2 pictures, but when you're directed in a slightly different way. Like they're telling you what quadrant to go to. Okay, like look at this first comment right here. It says, they're saying go spin between negative pi and negative 3 pi over 2. And then put these numbers on the triangle. Okay, so let's see. This would be negative pi. And if I keep going, this would be negative 1.5 pi. So I'm supposed to be in between here and here. That's what this means. Make your alpha, your reference angle, between negative pi and negative 3 pi over 2. So right in there, I was rotating negatively. That's negative pi. That's negative 1.5 pi. Okay, the alpha goes right here, the reference angle, close up that triangle, and put the numbers on the triangle. know where to put the 3 and the 5 because there's a definition for sine. It is y over r. Y over r. If you use Pythagorean theorem for that guy right there, you will get a 4. It is negative in that quadrant. Okay, now let's go build the other triangle because there's another comment hanging around there. The next one says, for number 12, this one's a little creepier. It says tan of beta is equal to negative 1 over square root of 3. We'll have to decide who to give the negative to. But it says draw your picture for beta between pi over 2 and pi. So now I'm going to get a picture going on for that. All right, now we're not rotating negatively, so that's kind of easier to think about. This would be pi. This would be half of pi. Turns out I'm in the same quadrant as when I was between negative pi and 3 pi over 2. Here I'm just going right in between here, because that's what that means. Beta is in between. Okay, put beta as the reference angle and toss those numbers onto the diagram. All right, let's see. I need to put them in the right place. I got to know the definition of tan. It is y over x. So let's see. I'm going to put this for the x. I'm going to put this for the y. In this quadrant, I know the negative was up at the top or maybe to the side or something, but really in the quadrant that you're in, the x has to be negative. So that negative really belonged to this guy. Okay, if you need to know what this y value is, it's going to be 2, I believe, because this is called r, hypotenuse. So r squared is equal to leg squared plus the other leg squared, which this would be 3, this would be 1, this would be 4. So if r squared is 4, r is 2. Because ultimately you would go like that. Anyway, I don't know that we'll need the 2, but now let's go back and do the problem. All that they mention in the directions, and I think there may be one on the practice test like this, all that they mention in the instructions just to build the triangles, okay? Not too hard. Now let's do what we actually taught in this section. Okay, so what we're actually taught in this section is, what's the question? There's a question here somewhere. Negative 2 for that?
Negative 3, because if the square cancels out the square root of the negative.
Oh, no, it does cancel out the negative, because you know what square means? It means take the number and the sign in front of it and multiply it by 2 identical. So that square means negative square root of 3 times negative square root of 3. So the negatives do cancel. All right, so the first question, I guess there's multiple questions here. Part A, here is sine of alpha plus beta. I can't do all these parts because it would just take too long, but here's part A. So it's sine of alpha. We got to expand this. Sine of alpha cosine beta. The sine formulas are a mixture of sine and cosine. If this is a plus, this is a plus. And then another mixture. It's just when I do the back mixture, I'm going to switch these. Alpha will now go with the cosine. Beta will go with the... I don't think that you should look at the pictures and jump into this part. You'll get too confused. Just write down the question, write the expansion, now start plugging it. It'll help you to focus. If you do one thing at a time rather than trying to think of the formula in your head at the same time you're plucking the numbers off the picture, that's too much. Okay, so let's see. Sine of alpha, I got to look at the alpha picture. The sine of alpha was 3/5. Cosine of beta. Cosine of beta is, let's see, x over r. Guess I did need that r. So negative square root of 3 over 2. Write the definitions if you need to. Sine is y over r. That's y over r. There it is right there. Cosine is x over r. That's the definition from chapter 6. So it would be square root of 3, negative square root of 3 over 2. Okay, come over here now. Looking at the beta picture this time for sine. I want y over r because I'm doing sine. So y over r, 1/2, cosine x over r, which is negative square root of 3 over 2. Oh, no, wait, I'm supposed to be looking at alpha here. So alpha, and I'm doing cosine, would be x over r, negative 4 over 5. Okay, got everything plugged in into the answer. So this would be 3 times square root of 3 with a negative out front over 10. Both of them have a denominator of 10, so I'm just going to write it as one big fraction. And then over here, negative 4. Okay, that's your answer. I would do more parts to that, but I've already done it in previous problems. I just wanted to show you how to build the triangles. Everything is snatched off the triangles. Okay, so I want you to, wherever it is that you were doing your work for those problems, continue working together. You need the practice, less of listening to me. Let me see if I have this. I got to turn this on. Hold on. Log in. I'm going to show you. Have you guys ever gotten on Socrative.com with me? No? Okay, so hold on 1 second. Instant feedback. Final score. Okay, so what you do to show yourself the problems in your own phone and to answer in your own phone or your computer, if you brought a computer, phone or computer, either one. Go to Socrative.com. And the first thing you're going to tap on student login, not teacher login. First thing it's going to ask you is, whose classroom do you want to go into? You want to go into my classroom. So just put Zeiss, and then it'll give you the opportunity to fill in your name. Can you please put your last name, comma, your first name? And there you will see all the questions which you guys were writing down. The only ones you're not going to see is I did add on a few more, because how many questions did you just write from that were up there at the beginning of the class? Like 7? And I guess there's 10 questions here, so I added on a few more. So those you'll just look at them right in here. All the questions are typed in here. Get on your phone. Now you have to log in on your own accord. Everybody has to have a separate grade here. When you get done, you're going to put your grade up at the top. Okay, you'll see the questions right there on your phone. Whoa. Ah! I hope I didn't knock you out. Hold on. Are you still in, or did I knock you out of there? You're still in? I don't know what just happened. Wait, I might knock you out. Did I knock you out? No. Not really sure what's going on. Show final score. Now I did? Sorry. You only had put in one. I was accidentally showing the answers. We can't have that. You guys probably want me to leave them on, don't you? Yeah, thought so. If you don't, is there anybody that needs to see them up here that doesn't have if you don't have a mobile device or a computer, let me know and I'll be happy to click on the questions so that you can see them. Hey, wherever you're writing your answers, can you make sure and take whatever multiple choice answer you're picking, write it to the side and circle it just in case we get caught short for time and you have to feed them in again possibly next time we're together? Because if you get short and you don't have time to do the last 2 or 3, that you can always just, next class, put them back in real quick, the multiple choices that you picked, and then continue with the last couple problems. Now, no pressure. Call me over if you need to ask something. Talk to the people next to you. Use your notes. It's meant for you to practice, so you can ask me whatever you need to ask. right. I'm putting the attendance sheet away. Did everybody sign in today? I'll bring it to you. Oh, yep, welcome. Here you go. Yeah.
So on the ones where we do the square root, that makes it plus or minus, so it's an all four, right?
Mm-hmm. But this should have been 3/4.
That makes sense.
Yeah, that's why you can't get it. But yes, it does make it in all 4 quadrants. Mm-hmm. Oh, thanks. Let me know if you need an example of anything. Sideboard. If anybody needs to stay in here with me to do homework or to finish these, I'm going to be in here for the next, until 1 o'clock, just sitting here. Oh, yeah. These are not grades. Don't worry, no one's seeing your grade. That's just how much of it you've completed. completed so far? Call me if you need me.
Number 7, and I factored out over here using x because
Okay.
I understand it better,
Okay.
but I rewrote it over here.
Let me just check it real quick. So 2% squared plus 2 plus another 3. Okay, the signs are not right.
Oh, there's a negative.
Yeah, so they just have, see, they're both the same, but this is what they both are, negative.
Okay.
Is that all it's going to take to
I think so.
fix what you had, the problem you had?
Yeah, because this wasn't even
Yeah.
one of the answers.
Yeah, that would cause a problem. Okay. Oh, I was going to get my phone. Oh.
Cosecant or cosine?
Let me look at it close. Is what supposed to be?
CSX.
Secant over. No, that's right. The answer's there. See, yep, the top is that. The top is secant, 1 over cosine. The bottom sine, and then you have to float and flip. You have to float and flip and multiply, and then you will find the answer right there. You just have to think about it. You just probably didn't do the float and flip yet, because otherwise you'll see. Then you'll see the answer there.
I'm just confused because it's just a CS. It's not like CSC or COS.
It's cosecant. Tell me if you still don't find it. You can leave if you're done. You can bring me the activity when you're done. Don't forget to put your grade at the top. I need your paper with all your work and the grade at the top. Then we'll have to just open it up again, I guess. I mean, I will be sitting in here for another 45 minutes if you want to stay and finish it. It's up to you. I don't know what you have to do after this, but you have to go after this? Okay, we'll just write all your answers. Make sure you write all the multiple choices that you chose. And then when you come back in, you can feed it in. How far away are you? You still got 6 minutes left. I don't know. You might finish it. Give it a shot. See what happens. If not, we can always do that. Thank you. You too. Thank you. Oh my God.
I think I copied it. When I looked at I'm like,
You're supposed to factor that factoring problem. If you look in the section that it mentions in Socrative, you'll see an example of it. Because I'm purposely putting stuff in here that, no, you're just factoring as though it was, see these trig words? You can replace them by x if you want. Just factoring 2x squared minus 5x. Cosine of theta would be the x, but here it's cosine squared, so it's x squared. That's all you're factoring. Like I see several people writing it like that first. Factoring it, and then dumping the word cosine back in there. Yeah.
Where do you want this? What do you want?
Yeah, I'll just have it right here.
It's not a question about one thing. Work it out. Wrong, but it wasn't. You get 3. That. Even a C and cosine.
Yeah, right. So
I didn't know what you wanted to do there.
did you get this from?
Right here.
That one right there? No, I thought that one was just, it started off 12 sine squared theta minus 9, right? Okay, I don't know what these are. They look like you were trying to square.
No, that's just the mark.
Oh, okay. So all you had to do, and you probably, let's just see if you did the same thing. You were supposed to bring that over there, and then divide by 12. It ends up being 3/4. And that's when you square root it, after you reduced it, because then you would recognize the number as 60, 30, 90. So take square root here, take square
So
root
then it
here.
would be 3 squared over 2.
Yeah,
Okay.
listen.
Yeah, okay. Thank you.
Yep.
No, here.
Thank you. Okay. We've got to put the title. Everybody, you should have a title on this because I might put these grades in 4 days from now. Maybe I'll put them in today, but I need the title so I know where to put it in the grade book. So do this. Just make